Hey, what's up? I've been getting a lot of emails with student anxiety. And so, since I study how people learn science, I figured I might share some things about the science of how people learn that might be of help in dealing with anxiety and dealing with frustrations of maybe feeling like you don't understand the material, and perhaps what I'm about to share can be helpful in terms of thinking about how you can budget your time and prepare for assignments and for tests in this class. So, for the tests in this class, you have the ability of bringing in a ton of information. You can bring the textbooks in, you can bring in your own notes, and that's for good reason because just having the content written down by somebody else is only going to partially help get the job done of being able to solve novel physics problems. So just having the text is only part of the game. You need to learn how to solve problems on your own. And that goes beyond having someone else demonstrate how to solve the problem. You actually have to take the initiative to solve problems on your own. So when it comes to the science of how people learn, we used to have this kind of old school view that knowledge was like some thing that you can give to somebody else. And that's just not how the brain works, okay? Knowledge is not like money that a teacher can just deposit into student bank accounts, if you will. Rather, the way the brain works is that we all have our own unique life experiences. And based upon our unique life experiences, we have a wealth of background knowledge that we bring to the table when we're presented with new information. And so, when we're presented with new information, that background knowledge plays a powerful role in how we make sense of that new information. It also plays a role in what aspects of that new information we pay attention to. You could probably imagine if you have two people and you present them the same sensory information, and those two people have very different backgrounds, those two people might attend to different aspects of the information. Now, not only is our attention different based on our background knowledge and how we recognize or fail to recognize patterns and things, but also with respect to how that information gets integrated into our brain. So, our brain has this complex web of neural networks based on our prior experiences and our prior knowledge. And so when new information gets integrated, it's getting integrated with our own unique neural networks. All of this is to say that when you actually actively take part in problem solving, when you're doing it yourself, when you're driving the car, if you will, that is the best way to actually make connections with your prior thinking. And that's where learning deepens because the more and more connections you make with your prior thinking, the more and more roads you can possibly take to get to that information, if you will. So, like, for instance, if you just like try to memorize something and just did it once, and then in the future you try to remember it and you can't, that doesn't necessarily mean that that information's not in your brain, but because you only did it once and you only did it one way, it's really limited the number of roads that lead to home, if you will, that lead to that information. If rather you do something and you do it again and you do it again and you do it again and you do it again, and when you're doing it actively yourself and making connections to your prior thinking and your prior experiences, that's laying down more and more and more possible roads in which you can get that information in your brain. So, more roads, more connections, if you will, in those neural networks means a greater chance that you're going to be able to access that information and use it again in the future. So, if there's a problem and you watch somebody else do it, it's not the same thing as actually doing it yourself because, again, knowledge is not like money that I can just deposit in someone else's bank account, if you will, okay? Knowledge is constructed, okay? It's not received. It's not like a student receives knowledge from a teacher, but rather knowledge is constructed by the person presented information and then making that knowledge their own. So, when you bring information into the tests, don't just have a bunch of information that has been put together by others, because that's how they've constructed their thinking about the matter. That's how they've organized their thinking. It's much, much, much deeper learning if you take that information and try to make it your own, to put notes in your own words. Okay? So take what you've been presented in terms of resources and try to put your own personal top spin on that information. Make it your own. Try to put it in your own words. Think about how you can make connections to other thoughts or ideas or experiences that you've had. Okay? Construct knowledge. When you just observe someone solve a physics problem, you are not constructing knowledge. Okay? You might be able to see certain things that they're doing that can be helpful for you down the line when you're doing the problems yourself, but there's no substitute for doing the problems yourself. So I cannot emphasize this enough. Physics is not a spectator sport. It's not enough just to read text and to look at lectures and to see how problems are solved. You have to do it yourself. And when it comes to the information that you can use in the exams, you're welcome to bring many different resources, but the more you can make those resources your own by putting them in your own words, organizing them in your own way, the more you're actually constructing your own knowledge. Because again, knowledge is not some inert thing that gets passed from teacher to student, but rather knowledge is constructed, and that construction is unique to each of us because we all have our own unique prior experiences, our own background knowledge, and that's what's getting integrated with the new information. And so every knowledge construction by each individual knower is going to be unique. And so I can't emphasize enough, it's not enough just to see information presented to you. You have to try to make it your own. It's not enough just to see a problem worked out. You have to do the working out on your own as well. And at first it can be challenging, but I assure you, if you put in the time, if you put in the patience, if you're willing to accept that it could be difficult at first and you might get stuck, okay? That's okay. That's natural. That's part of the process of getting better. When you get stuck and you persist and you overcome the challenge, you will gain confidence and you have more and more opportunities to make the thinking your own. And so the more and more problems that you practice where you're actively doing them, you're taking the lead on solving the problem, the more and more you're going to begin to recognize certain patterns, certain strategies that you find helpful. When you take the test, you're going to be doing a problem you haven't seen before. But if you've been doing lots and lots and lots of practice problems, you're going to begin to see that while ostensibly it might not exactly be the same problem, you're going to be like, hey, I've done a lot of problems like this before. But you don't recognize those patterns and those relationships unless you put in the time and you do the practice. And again, you're the one that's driving the car when you're doing that practice. That's the deepest way of learning because you're doing construction of knowledge as opposed to watching and observing how others have constructed the knowledge.